Okay, so we are looking at bonds, chemical bonds, and yesterday or the last couple of days we've been talking about the different types of bonds. So I wanted to compare and contrast those different types of bonds. So can somebody tell me something about any bond, whatever? Why do atoms bond? Well, I mean, that could be something common. Why do they bond? They want what? Just to share valence electrons. What else? What? I showed a whole graph, and I said chemical bonds is favored by nature. Why?
Because it makes a more stable atom.
Makes a more stable atom by how?
By not having things like chlorine by itself, because it has less energy.
Because it lowers potential energy. Okay, so everything they bond because to lower potential energy. So tell me about ionic bonds. What can we say about ionic bonds? They transfer electrons. Okay, what else can we say? How can you tell an ionic bond from another bond? Metal and a nonmetal. What about a covalent bond? What can we say about covalent bonds? Nonmetal and nonmetal. And what do they do with their electrons? They share them. And then, of course, you had your metallic bonds and the sea of electron. But what about the properties? The properties in general. If I gave you two chemicals and had you go back there, two compounds and had you go back there and manipulate them, how would you know what was a covalent compound and what would you know was an ionic compound? How could we tell that? By their properties.
Compounds are crystalline.
Okay, ionic compounds are crystalline. While what can we say about molecular compounds? Low boiling points. What else? They conduct electricity. We could take two compounds and make a solution out of each one of them and determine if one conducts electricity or not. If one conducts electricity, then it's ionic. Okay? Those are going to be things that you are required to know for your test. So, next Friday. And it is not open note, so I would start studying a little bit each night, because it's not going to get any easier than this. All right. So today we're going to talk about how to determine a bond, an ionic bond from a covalent bond, and then the two different covalent bonds. So how do we know an ionic bond? So what is we're going to look at electronegative values. So what is electronegativity?
The overall charge?
No. Electronegativity. Electronegativity is the ability for an electron or for an atom to attract electrons. Who is the most electronegative atom?
Any atom that's as big as
No. There's one atom out there that is very electronegative, and it is fluorine. You better know that. Why? It's just what it is.
Wait, fluorine is
It's the most electronegative. You'll see that question on the ACT, any standardized test. Next is each one of those atoms has an electronegative value. Now you can easily tell me what an ionic bond is, because we know that it contains a metal and a nonmetal. But a covalent bond, there are two different types of covalent bonds, right? There is polar and nonpolar. So they're both made out of nonmetals. And so you can't just say, oh, that's a nonpolar bond, or that's a polar covalent bond. we have to look at electronegative values. This is kind of what you're doing on your homework, at the bottom part of your homework.
Which one shares them equally?
Equally is nonpolar. Yes.
What is electronegativity?
Electronegativity is the ability to attract electrons. Ooh. All right. So all of these have numbers, and there are some parameters set for you to determine if it's ionic, covalent, polar covalent, or nonpolar covalent. And these are those parameters. You just need to memorize them. That if I take my two electronegative values and I subtract them, if the difference is less or 0 to 0.3, then it is nonpolar covalent, which means that it is sharing those electrons equally. If I take those two numbers and I subtract them, and it is greater than 0.3, but it is less than 1.7, then it is a polar covalent, which means that it is being shared unequally. And if it's greater than 1.7, then it's an ionic bond, which means that we have transferred an electron over. So I might give you the values. You might have to get that difference and figure out if it's polar covalent, nonpolar covalent, or ionic. You may have to look it up on a chart. You're given a chart and you have to figure out those numbers. Or you might just be given the numbers or the difference. Okay? So is there any questions on those? Those parameters, you need to know those. Yes? Well, I'm going to show you. All right. This is a very bad illustration, but you can find these on the internet. There are numbers here. This says 2.2, 2.0, 2.0, 1.9, 1.8, 2.0, 2.0, 2.2, 2.2, 2.2, 1.9, 2.2. All right, there are numbers there. That's its electronegative value. Here, francisium is 0.7, while over here, fluorine is 4. My noble gases do not have values because they don't want to attract electrons. All right, so they don't have electronegativity. So when I give you two atoms, you go and find those numbers. I give you, say, tellurium, and you go find its number, which is 2.1, and aluminum, 1.5. And we're going to subtract them. Take the difference. Okay? So here is some practice. I have already gone and gotten these numbers because it's just easier. So I went back to that chart, the chart prior, and I went into sulfur and found its number. And sulfur's number is 2.8. Cesium's number on that chart is 0.8. The higher your number, the more electronegative you are. So in this case, the more electronegative atom is, which one? Sulfur. The more electronegative? What's the difference of these two numbers? 2. So what type of bond is it? Ionic. I can also tell it's ionic how? Metal and non-metal.
Will we get that chart on the test?
You'll either have an insert of the chart or, yeah, if you need it, you'll have the numbers. Huh?
Is it going to be easy to read?
Yeah, it'll be easy to read. All right. the next one, I have chlorine and bromine. So chlorine is 3.1 and bromine is 2.9. So who is the more electronegative? Chlorine. What is their difference? 0.2. So what type of bond is it?
Why is it non-polar?
Nonpolar. Look at the periodic table. What is the distance between chlorine and bromine? They're pretty close together? Like right on top of each other, right? If they're right on top of each other, it's probably a non-polar. Most likely, 9 out of 10, it's going to be a non-polar bond. If they're right next to each other, 9 out of 10 times, it's going to be a non-polar bond.
What's that 1 out of 10?
Huh?
What's that 1 out of 10?
I mean, sometimes like carbon and nitrogen, sometimes there's just some weird things in there. Nitrogen and hydrogen. The value for nitrogen is 3, and hydrogen is 2.2. Most electronegative is nitrogen. The difference is 0.8. So what type of bond is it? Polar. Again, look at the periodic table. Look where hydrogen is. Look where nitrogen is. Pretty far apart.
Wait, why did you put in the more right?
Because its number's bigger. It's 3.0.
Oh.
Iodine and iodine. This should be pretty easy. Both of them are 2.6.
This is non-polar.
So it is nonpolar. Any diatomic is going to be nonpolar. And lastly, calcium and chlorine. Calcium is, does that say 1.0? Chlorine is 3.1. Most electronegative is chlorine. The difference is 2.1. So what type of bond is it? Ionic. Okay? So that's your homework tonight. You have all those pairs, and you have to say, is it ionic or covalent, or ionic, polar covalent, or non-polar covalent?
Are we done?
No. Questions? All right. Here we go. We are going back to electron dot diagrams. We are actually going to show the transfer of these electrons in an ionic bond. And we're going to show transfer of ionic bond, and we're going to show sharing in covalent bonds. So knowing how to draw these structures is very important. So having that colored periodic table or whatever in front of you is going to be needed. So you can quickly tell me valence electrons. So electron dot diagrams. These are representing our valence electrons, right? What is the most valence electrons you can have? 8. Okay? 8 is the most we can have. Everybody wants to look like a noble gas. So calcium. How many valence electrons does calcium have? 2. 1, 2. I put them next to each other because that's representing the s orbital. Now, you could have put them somewhere else. On the other side, it doesn't matter. Your s orbital might be somewhere else. Okay. Calcium ion. The calcium ion, what happens from calcium to calcium ion? What happens from one to another? Does calcium want to lose these 2, or does calcium want to gain 6 more? Lose 2. So in the calcium ion, calcium, those 2 go away. So we had these 2 here, and we have a charge of 0. Those 2 electrons go away, and now what's our charge become? Positive 2. Calcium lost its 2 valence electrons. How many valence electrons does it have now?
8.
It still has 8 valence electrons. I'm not showing it there, but it has 8 valence electrons because now calcium looks like argon. Oxygen. How many valence electrons does oxygen get? 6. 1, 2, 3, 4, 5, 6. I do 1 in each for the p orbitals. Nitrogen gets how many? 1, 2, 3, 4, 5. Sulfur gets how many? 1, 2, 3, 4, 5, 6. We're going to do a sulfur ion. So here's regular sulfur. It wants to gain or lose electrons. So what's it going to do? It's going to gain 2, and I'm just going to go ahead and put those 2 there to show that it gained those 2. And what's its charge become? -2. On your homework, it's going to say the you do nitrogen, and then the nitride ion. You're going to go, where's nitride on the periodic table? Nitride is nitrogen. It's just changed its name. So you're going to look for that root name. Magnesium, how many does it get? How many valence electrons? 1, 2. Chlorine, how many valence electrons? 1, 2, 3, 4, 5, 6, 7. Iodine, how many? 7. 1, 2, 3, 4, 5, 6, 7. And lastly, potassium gets how many? That's K. 1. Potassium ion would look like that. Okay? This helps me to determine how are my electrons going to move. Am I going to move electrons over to here, or am I going to move electrons over to here? Okay? Looking at those lets me see how electrons are moving. And that is very important. Everybody good with the valence electrons? All right, we're going to do some transferring then. Ionic compounds. We are going to do electronic structures for ionic compounds, which means this is going to be for a metal and a nonmetal. The very first thing you want to do is I'm going to give you a compound, and you're going to write the dot structures for that compound, for each one of those elements. Okay? Once we've done that, then we're going to draw arrows from the electrons of the metal to the nonmetal to show the transfer. So let's do an example here. We are going to do calcium chloride. Again, chloride is chlorine. It's just an ion. All right, so first thing, structure for calcium. How many dots does it get? 2. We're going to draw the structure for chlorine. How many dots does it get? 7. The overall goal for bonding is so that the atoms can have 8 in its outer shell, be happy, and be stable. Right now, they don't have 8 in their outer shell, and they're not happy. So we need to make them happy. So to make them happy, we're going to move electrons. We're going to move electrons from the metal to the nonmetal. Metal to nonmetal. So I'm going to do that. So I'm moving an electron from calcium, and it moves to right here. And that's where that electron is now, in chlorine. Chlorine went from 7 electrons to 8. Is it happy? Yes. What is this charge on that chlorine when it gained that 1 electron?
0.
A -1. Is calcium happy? No. So I need to add either another calcium or another chlorine so that we can get it happy. So we probably need to add another chlorine. So we're going to add another chlorine. And I'm just going to add it over here. Doesn't matter where you add it. And calcium's going to transfer its electron over there. Is chlorine happy? Yes. How many? What's its charge now? -1. Is calcium happy? He lost those 2. Yeah, he's happy. So what's his charge? +2. Okay. So everybody's happy. 8, 1, 2, 3, 4, 5, 6, 7, 8. He's happy because he lost those 2 and he has 8 in his outer shell. 1, 2, 3, 4, 5, 6, 7, 8. And now chlorine's happy. What is the overall charge of this whole compound? -1 + 2 -1. The overall charge is what? 0. The overall charge must be 0. So you better keep adding until you get an overall of 0. Every time on an ionic compound. So let's write its formula. Metals always first, calcium. And we're going to put the number of atoms as a subscript right to the right side of it. If the subscript is 1, it's an understood 1. So calcium, yes.
Are you going to have 2 calciums now? Or not, chlorines?
Mm-hmm. So calcium has a imaginary subscript of 1, and now we're going to add chlorine, and chlorine gets a subscript of what? 2. There's our formula. In your homework, you have to show the transfer and then the formula.
Wait, let's say it's messed up and it was like a negative charge. So what would that look like? The NaCl like put together?
Wait, what?
That had a negative charge?
A negative charge?
Yeah.
Overall?
Yeah.
In some cases, it can.
What would it look like if you wrote it like you just did?
Oh, like that? Oh, no, in this case, it wouldn't have one. Not in this one. And the non-metals, we can get them in the covalent, but not in ionic. All right. We ready to do another one? Because I'm going to trick you guys up. You think it goes on forever, but it's not going to go on forever. So let's do another one. This time, we are going to do, what's it say? Magnesium. Nitride. Again, nitride is nitrogen. So, the very first step, draw the dot structures for each one. So, I draw a dot structure for magnesium. He gets 2 valence electrons. Nitrogen gets how many? 5. It doesn't matter where you draw them.
It doesn't matter where you draw them.
So how do these electrons move? From Mg to N or N to Mg? Mg to N. So magnesium moves an electron. Everybody happy? No. Mg moves its next electron. Everybody happy? Who's happy? Magnesium. He now has a +2 charge. But nitrogen's not happy. So we need to add a magnesium. So we've got that magnesium out there, and now it's going to transfer its electrons. And it's going to take an electron, and then it's going to transfer it to nitrogen. And nitrogen's happy now, right? Nitrogen's charge is -3. Now magnesium's not happy. This is a relationship, all right? People give and take in relationships. atoms give and take in chemical bonds. Okay? So magnesium's not happy, so we need to add another nitrogen. So we transfer that one over there. Now magnesium's happy in this relationship with his +2 charge, and nitrogen's unhappy. So we got to find somebody for nitrogen, and that would be another magnesium. Right? And so now magnesium transfers one over. Both of them are unhappy. Magnesium transfers the other one over. And when that happens, both of them are happy. What's the formula? Mg3N2. What's the overall charge? 0. +2 minus 3 +2 minus 3 +2. When all of those come together, it better equal 0. And it does. Not when I'm doing this, no. Not when I say you need to show me the transfer, no. Yes?
So fast, 4 valence electrons, is it gonna lose them or gain?
That's in a special situation. It depends on if you're talking about the nonmetals or the metals. So like carbon is usually going to, the nonmetals are weird. The metals are usually going to gain. Or sorry, not gain, are going to give up the electrons. Okay, so those are kind of weird. We don't really ask you to draw that. All right, so let's do one more practice. There's the rules on what to do. So here's some practice real quick. K has a charge, or has how many valence electrons? Fluorine has how many? 7. K is going to move over. K becomes a +1, F becomes a -1. So my overall charge is 0, so I'm good. And now let's write the formula. KF.
Why is the F just
Huh?
Why is the F just is it just happy?
Because it's happy now. It came in with 7 and it gained 1. You guys ready to do, y'all want to do one more, or are you ready to do your homework? Homework? Yes?
Yeah.
Okay, so your homework is the rest of that page. I'll be checking it tomorrow. So I'm going to check it all together.